Okay, folks, tonight's video is about rate of change, hence the ROC, R-O-C. And this is the lead-in for the next lesson. It's going to connect to the us finding limits. But just so you know, the rate of change of something is what's known as the slope on a graph. So, for example, if I have this function right here, the rate of change is the slope at any point in time. And I'm drawing little tangents to show what the slope is at those particular points. This over here is a positive slope, it's a negative slope, and this is a positive slope right here. Now, how do you normally find slope on a graph? You make a function here. We're going to call that function y. I'm going to call this the x-axis. And what normally happens is you take 2 points on the graph. You take a y1 and a y2. I lied about that. You got me. You take an x1, y1, and you take a point x2, y2, and then you find the slope between those two. And you do that by using what's called the slope formula, and you guys have seen that before. Slope equals rise over run. It's also known as the change in y over the change in x. I'm intentionally showing you all these different symbols, and the way you've seen it in the past is y2 minus y1 over x2 minus x1. We're going to make it, so in order to do this, in order to find the slope, you need two total points. One to put in for the one and one to put in for the other one. Now, I'm going to change the symbols we're going to use slightly. Instead of using y2 minus y1, I'm going to call this graph f of x. I'm going to pick a point A. I'm going to pick a point B. The point on the graph that associates with A is f of A. That's the value of the graph at A. And this is the value of the graph at B. Same thing as y. It's a y value. It's another y value. But we're going to talk about slope being equal to f of b minus f of a over b minus a. I call it fib-faba. It comes in handy to memorize it in this form, even though it's the same as saying, I'm writing over the top, I know that's weird, y2 minus y1 over x2 minus x1. The b's, the a and b, are just two different x values, whereas the other two are two different y values. Let's erase those off of there. So, in order to find any slope, we're using 2 points to find the slope, and that's known as the average slope. It's the slope between 2 points. Now, if you look what I did back in the beginning here, I was looking at slopes of just 1 point. I was trying to find it at just one value. So we're going to try to see if we can do it that way by using just 1 point, and then we'll be done and ready for the next class. I'm going to make the graph y equals x squared. Now I'm going to make it f of x. F of x equals x squared. And what I'm going to do is I'm going to pick 1 point and try to find the slope at that point. This is the point 3, 9. I'm going to use that same point twice. And I'm going to do f of b minus f of a over b minus a, except I'm going to use the same point. So I'm going to go f of 3 minus f of 3 over 3 minus 3. The value of the function at 3 is 9. So it becomes 9 minus 9 over 3 minus 3 equals 0 over 0. Hey, 0 over 0, is that undefined? No. That value is indeterminate. We can't find what's going on using the information we had here, because we used the 2 points at exactly the same spot, so it didn't end up working out. I'm hoping there's a way we can try to find, or get close to finding the slope at 1 point. It's also known as the instantaneous slope, because it's the slope of an instant. But we'll give a shot to that more in the next class. So this, you don't have to fill in the notes right now. This just leads into our notes for Monday. And I shall see you then. Take care.